electric force between two very long uniformly charged wires or threads. In the present problem, what is the scenario? We have two very long, that is the infinite model, two very long uniformly charged rods or wires or threads, whatever you may say, and both are oriented perpendicular to each other. What it means, suppose this is your one rod is going vertical, okay, say of density lambda 1. So another rod is like this in the horizontal plane, and the distance between the rods is small a. So it's a 3D figure, something like this. This second rod is not exactly in the plane of the board. The second rod is perpendicular to the plane of the board, okay. So if you make a more precise and technical figure, so your figure would be something like this. Your one rod, say lambda 1, is in the plane of the paper, I will say plane of the board, and your second rod, say of density lambda 2, is perpendicular to plane of board, okay. You will say the perpendicular to plane of paper, and the distance between the two rods is small a, and both are very long rods or threads, so we can use the infinite model. Now what we need to do, we have to find the electric force or the electric interaction or the Coulomb's force between the two rods, okay. So as we have seen in the fundamentals, whenever you are finding the electric force between two extended objects, you can choose one object as the source, another object as the target. And because of the source, we will find the electric field at the location of the target, and then due to this electric field, we will find the force on the target. So that is your choice among the two rods, which rod you are taking as the source and which rod you are taking as the target. So say taking rod with density lambda 2 as the source and with density lambda 1 as the target. Of course, both will exert electrostatic force on each other, and the pair will be forming action reaction pair of Newton's third law, correct? So you can find the force on any one. The magnitude of force will be same. Force is exerted by rod 1 on rod 2 will be equal in magnitude and opposite in direction to the force exerted by rod 2 on rod 1. So what I am doing, I am taking the source as rod 2 and I am taking the target as rod 1, okay. So basically, as we did in fundamental, whatever we will find the source at the location of the target. Now we know whenever we have some very long wire or thread perpendicular to plane of paper, we have long thread or wire perpendicular to plane of paper, say with a density lambda, and there is a target point P, and you have to find the electric field because of this thread or wire or rod at a point P. What we do? First of all, we join the target point with the location of the wire, and then we take the outward model and we'll make the field like this, and the field is magnitude is what? 2k lambda divided by r, where r is what? The distance between the wire and the target point. So this is the fundamental formula which will be employed in, okay. So say this is your second rod which has a density lambda 1, which will be treated as the target, and this is your another rod at a distance of a with a density lambda 2, which will be treated as the source. The approach is that we will find the electric field because of the source at the location of the target. Now see, when you will apply this approach, so different points at the location of the target, that is different points at the location of one, are at different distances from rod 2. So suppose you have to find the electric field at this point, say at a distance y, and this angle is theta, and say this distance is r, so r will be what? Y square plus a square under root. So applying that basics, the electric field due to the wire lambda 2 will be like this, outward, and this field will have a magnitude of how much? 2k lambda 2 divided by small r. Let it be equation number 1. This is the electric field. This is the electric field at a point, say P, at the location rod 1, okay, is the electric field due to rod 2 at point P on the location of rod 1, because we are treating the rod 2 as the target, sorry, as the source. We are treating the rod 2 as the source. So whatever is the source, we will find the electric field because of that object, and now because of this field we are going to find the force on the target. What is the target? Rod 1. Now the point is that when you put the value of theorem, r will be under root y square plus a square, so E will come to be 2k lambda 2 divided by y square plus a square under root, correct? So your value of electric field is depending on the value of y. Got it? The value of the electric field is depending on the value of y. So it means that and change on rod 1. So this is, I'm taking as a reference point the foot of the perpendicular at O. So y is denoting what? The distance of the point P, the distance of the target point P on first rod from its reference point O. So for different points on the first rod, y will be changing. So y is basically a variable. So at each point, the electric field will be changing in the magnitude because it depends on y, and also changing in the direction, correct? Because you see at this point it is like this. If you are taking a point here, the field will be like this here. So electric field is non at the location of rod 1. So if you now want to find the force on rod 1, so we will apply the basic, we will apply calculus, because rod 1 is an extended object, so we will take infinitesimal charge. So we know the basic, if there is a charge dq in some electric field E, then this electric field will apply electric force dF E on this charge, and dF E would be what? dq into vector E. This is a vector equation, so we are not putting it. Direction of dFE will depend on the sign of dq. If dq is positive, we all know dFE will have the same direction as that of the electric field. If dq is negative, dFE will be in the opposite direction. So now what I will take a charge element on rod 1. So this is say y, and I'm taking a charge element of thickness dy. This is what? A charge element, that means an infinitesimal charge, say dq on this rod, and this is another rod lambda 2, this is lambda 1, and this field E1 will exert a force on dq in the direction of the field, something like this, correct? So let it be dFE, correct? dFE, and this is your what? A, and this is R. Now what will be dFE? dFE will be dq into E, correct? I'm writing capital Q. dq into E. Now what will be dq? So dq is the charge element on the rod 1 where the thickness is dy. So dq will be lambda 1 into dy. So therefore dFE would be lambda 1 dy, and what is the electric field? Twice of k lambda 2 divided by y square plus a square whole under root. So this is the value of your infinitesimal electric force on that charge element. This is the value of your infinitesimal electric force on that charge element. Let it be equation number 3. Now force on this particular element. Now there will be a tremendous number of such elements on rod 1 and each element would experience some electric force. Now all the electric forces will vary in the direction. As you know, this is going like this. When you make a force here, it will go like this, correct? Suppose you are making a force at some lower point like this. So this here DFE, here the electric force would be something like this, correct? So your DFE is continuously changing in the direction. So if you want to find the total force on rod 1, so we have to integrate, and force is a vector quantity, then we have to go for the vector integral, and we all know the basics of vector integral need to be done on different axes. So we have to, it's not a 1D case, so we have taking the coordinate system, because before taking the axis we have to take the coordinate system. So I'm taking this as the y axis, okay, and I'm taking the left side as x axis, and this is the element at a point P, correct? So I can take resolve DFE in two component, one along the y axis, one along the x axis, and if this angle, this angle is theta, so this angle will also be theta. So this component will come to be DFE cos theta, and this component will come to be DFE sin theta, correct? Now see, before proceeding the axial integral, before proceeding with the integration on different axes for the vector, always have the consideration whether some symmetry is present in the problem which might help you in getting a bypass through some integral steps. So in the present problem, if you see, the rod is uniformly charged. If the rod is uniformly charged, if you take any element of same thickness, any element, it will have the same charge. So we can take advantage of the symmetry. So if I am taking a symmetric element located below point O, okay, this is a symmetric element, that foot of perpendicular is point O, take a symmetric element located below point O, so this distance would also be y, and this will be dy, and say this is a charge dq dash, and of course dq dash will be equal to dq because lambda is same. So here the force would be like this because electric field will be same. So say we have a force DFE dash. Okay, now what will be DFE dash? So since lambda is same, both electric field will have the same magnitude. So DFE dash will have a magnitude of DFE, same magnitude. Got it? So why we did this thing? Just to take advantage of the symmetry and making our working a little bit of, taking the bypass route. We can skip out one of the integral, okay? So what happen if you take the components of this lower elemental electric force, so we'll have a one component downward, one component this side. If this angle is theta, this will also be theta, so this will be what df dash cos theta, and this is what df dash sin theta, correct? On y axis, so we'll say net dfe on the y axis will be what? So that is sin theta can be taken as a common factor. We have dfe along the positive y and dfe dash along the negative y, and from equation number 4 you can see both are equal. So therefore dfe on the y axis will be 0. So it implies that if you find fy, that is the integral of dfey and something 0, on integration will give you 0. So you have no field on the y axis. That is the advantage of symmetry. You can also go without symmetry, as I always tell you. Symmetry is the advantage, not any foundation that you have to follow it. So had you gone without symmetry, so you would have integrated along the y axis by taking the component de sin theta, and when you would have integrated for the whole line 1, it would itself come to be 0. The symmetry is giving you the advantage, it is giving you a bypass road to save your time, to save your steps for the integral on the y axis. Now let's come. So what is your dE dFE x. So both the components are on the positive x-axis, so we'll get cos theta dFE plus dFE prime or dash. So, and both are equal in magnitude, so we can write 2 of dFE cos theta, correct? This is infinitesimal electric force on the x-axis. Now if you want to find Fex, it will be d Fex. Now just think, when you will be integrating, whether you need to integrate the complete rod 1 or you need to integrate half of the rod 1. So of course you need to integrate half of the rod 1 because you are simultaneously taking two elements. So we will be integrating half of rod 1. Let's put the value of dFE. So Fex will be integral of d twice of d Fe cos theta. So we'll get twice of, and what was Fe? F was, I guess, where we find dFE, 2k lambda 1 lambda 2 dy, 2k lambda 1 lambda 2 dy divided by a square plus y square under root. Now put the value of cos theta. So if you see the right angle triangle, what is coming to be cos theta? Base upon hypotenuse, that is a divided by r. So you'll get a divided by r, and r is what? A square plus y square under root. You will get net force on the x-axis as 2 into 2, 4 is a constant, Coulomb's constant, lambda 1 and lambda 2 are constants. You will get a divided by, now this won't come out of the integral because y is variable, so you'll get a square plus y square multiplied by dy. Okay, now this is the integral. Now we have one skill how to solve this integral. So there is a standard formula for this integral. You can also see the description link where I have proved how this integral comes. Here I am simply writing the end formula. If you want to see the proof, what is the process of getting this answer, you can click the link given in the description. This comes to be 1 by a tan inverse y by a. This is the formula of this integral. Okay, you note it down. And if you are interested in going through the proof of this equation, this integral, how it came, then you can click the link in the description. If you are interested, there is no need, or if you don't know, don't want to know the proof, you can directly apply the formula. Okay. And you know, tan pi by 2 approaches infinity. Tan pi by 2, we all tan 90 approaches infinity. So whenever you have something like, suppose you are writing tan x, and if you are given, if you are writing tan inverse x, okay, and say x approaches infinity, x is approaching infinity, so tan inverse x will be equal to what? Pi by 2. You know the inverse trigonometric function. So if the argument of the inverse trigonometric function is approaching infinity, so we know the angle would be pi by 2. So these are mathematical basics which will be in this case. Now we will integrate. So we'll put the limits of y. We are in a position to integrate because you know we have a square and y square. A is constant. So integrand is the function of y, and we are integrating with respect to y. So we'll put the limits of y. So y will begin with 0, not with minus infinity. You see, line 1 is infinity. So it is extending from minus infinity to plus infinity. If you see the value of y is beginning from which point? This is y is beginning from point O, that is a foot of the perpendicular from lambda 2. So for this point y will be 0, as you go above y will be positive, as you go below y will be negative, correct? And if you go to the end point above, y will approach infinity, in the bottom point y will approach minus infinity. But since we are integrating half of the rod, so y will run from minus infinity to infinity. So y will be 0 to infinity. So I have what? 4k lambda 1 lambda 2 a. Now what will be the integral? You will get 1 by a tan inverse y by a. Okay, now put the limits. So your y will begin with the value of 0 and y will ends at the approaching value of infinity. So I will have what? 4k lambda 1 lambda 2 a will come outside and you will get tan inverse. Now this will approach infinity, correct? Minus tan inverse of 0 from 0 to infinity. Now already I have taken the limits, so no need to write the limits again. Now since final y is approaching what? Infinity. So tan inverse y by a will be what? Pi by 2, and we know tan inverse 0 is 0. So your net force on the x-axis will be 4k lambda 1 lambda 2 a will get cancelled away and you will get what? Pi by 2. This is the answer. If you're finding, since Fy is 0, so net force would be Fx square plus Fy square, and Fy has no value, so it is simply not of Fx, so you'll get 4k lambda 1 lambda 2 pi by 2, that makes 2. So this is your answer. If you want to put the Coulomb's constant value, you can always put the last step if you want to give your answer. So 2k is what? 1 by 4 pi epsilon naught lambda 1 lambda 2 pi. Now pi will get cancelled away, 2 will get cancelled away. Your answer is lambda 1 lambda 2 by 2 epsilon naught. This is the answer. And the net force is acting where? Along the x-axis. This is your answer to your first part. If we have an infinite rod, something like this, another rod is like this. See, this is lambda 2 and this is lambda 1, and they are oriented perpendicular to each other. You got it? One rod is where? In the plane of paper, for example, in plane of paper, and this rod is perpendicular to paper. So on this rod, force is acting this side, and on this rod, by Newton's third law, force will act this side, equal and opposite, and force has a magnitude of lambda 1 lambda 2 by 2 epsilon naught. Okay. Now in the second part, we have to tell how this force depends on the value of A. That is, how this force depends on the distance between the rods. So you can see the force is independent of the value of A. Force is not depending on the value of A. Can you see? So this is very interesting thing. F is independent of A. Okay, so this is the complete solution of the problem. Got it?